Welcome back to our statistics learning session. Today, we'll be talking about two sample two sample t-test. For this, we have to go back to our cholesterol example. Here, it's a bit trickier. In this, we have Tn. We have a test statistics, which is Tn, which is equal to xn bar minus yn bar ym bar minus delta d minus delta c divided by sample variance divided by n plus sample variance divided by m and square root of that is divided by that. If we didn't have this sample variance, then this would be equal to, this would have a Gaussian distribution. But since we have a sample variance, this doesn't have a Gaussian distribution, but this has something more closely related to a student distribution. And it has a freedom of n. It's a distribution of student distribution with freedom of n variables. And that's what we have here. Now, question comes, how do we know that what is the, how do we calculate the degree of freedom for this particular expression for Tn? How do we calculate that? We can calculate the degree of freedom in two ways. One is a one is the easier way where we calculate, we have a two population NMM and we take the minimum of that, and that becomes a degree of freedom which is equal to n. Secondly, we can calculate the degree of freedom by plugging using the Welch stature weight formula, where we have a different variable such as sample variance delta, sample variance for delta for C, sample variance delta C, sigma C, n, and m. If we know this, then we should be able to calculate the n. Therefore, this formula depends upon the estimated sample variance or estimated sample variance. Now we have completed this slide. Moving to the next slide, where we'll do an example. In this example, we have values for different variables such as n is 70, n is 70, and m is 50. N is 70, m is 50, xn is 156, ym is 132. Sample variance for D is 5198. Sample variance C is 38867. If we do that, then when we compute this, it comes out to be 1.948. It comes out to be 1.948. Now, next step, we need to calculate a p-value for this. We can calculate p-value using two ways. First of all, let's do a shortened formula where we calculate the n which would be the minimum of N and M. And what is the minimum of N and M? It is 50. And therefore, we have a Q at 5%, which is standard. Alpha 5% is 1.68. Therefore, P Tn Tn 1.9248 equal to, this would be equal to 0.029974. This is a simple formula where we use a shorthand formula to calculate the n, which is n, which is the degree of freedom. Now we need to calculate the second way of calculating the n, and hence again calculating the p-value for that. The second way of calculating p-value is using the formula, or the Westchester formula, where we plug in all those values, and once we plug in all those values, we get 113 degree of freedom. Now, now, should we round this up or should we round this down? What do you think we should do? We should always round down because we have to be conservative in degree of freedom. We Degree of freedom is a number of observations, and we want to be always conservative on number of observations, and therefore we'll be reducing the degree of freedom to lesser value, which is 113. And then if we do that, then we have to again calculate the p-value, where probability that Tn, which is 113, is greater than 1.9248, and we should be equal to around 0.2832. How do we calculate the this t? This t is calculated using the student distribution chart, and from there we get quantiles of the student distribution, and thus we calculate this. This is usually the quantile of Tn minus 1, and we calculate 1 minus alpha by 2 of quantile of Tn minus 1, and that's how we are able to get this value. We usually get this value from the online system, where we input those parameters 113 for a student distribution, and then we get a 2832, 0.2832. Now let me summarize what we discussed today. We discussed about two sample t-tests. For this, we went back to our cholesterol example, and then we calculated the test statistics using a given formula, and this test statistics was had a uh, student distribution with n, and where n was n equal to minus 1, where n was n minus 1, this n was equal to n minus 1, and then we went ahead and computed the n minus in two ways. One is by minimum value and one is by formula. And then we did an example where we were given some sufficient statistics to calculate the n and then p-value using both ways. So that's all for today. I will see you next learning session. Thank you so much.